Two cases. Okay? Think about even index radical. When I say an even index radical, what do I mean?
This 7.3 B.
Yep. Even index radicals, square roots, fourth roots, sixth roots, eighth roots, 10th root, and I go on forever, right? What can I not have inside of a square root? Negative. Okay, same thing with the fourth root and the sixth root. Cube roots, fifth roots, I can't have negatives under those, right? Okay. So even index radicals, that's going to be your indicator that we have a restricted domain. Not always, but 97% of the time you will. Okay. Yeah. What's that?
I can go to the bathroom. Make it a bath.
Oh, let's get that.
Sorry,
forgot
what
that.
bath am I supposed to?
You did start it?
Yeah.
Oh.
I'll just choose a random bathroom and then just go to whichever one's closest. So if I don't.
Yeah, go ahead, bud. All right, so again, even index radicals, we can't have a negative value inside there, right? Okay, that's going to cause us a restriction. And when we write those restrictions for those radicals, it's going to be an inequality statement. Okay. We got to get rid of a set of numbers, okay? Because there's going to be many values that cause it to be negative inside, right? Now, the other case where we have a restricted domain is whenever we have that variable in the denominator. Because what's the one value you can't divide by? 0. And typically, it's one specific value, right? I shouldn't say one specific value. Okay, it's a specific value or values that cause it to be 0, right? Depending on what's in the denominator. Okay, so this is going to be a specific value that we have to exclude. So that's where we'll say x cannot equal whatever values that cause it to be 0. Okay. Now, if you say no to both of those, so we have an odd radical and there's no denominator. Okay, it doesn't follow either of those cases, right? If that's the case, it's x the element of all the reals. Doing these, you got to ask yourself, do I have that even index? Okay, what's going to cause that to be a negative inside? Okay, do I have a denominator? Yes. Is there a variable down there? Yes. Then I'm going to have some type of restriction. Okay, we got to figure out those restrictions at that point. So again, domain is those x values that we can plug in and get something back, correct? Okay, so we got to make sure, I got to figure out what values I can actually plug in. Right, so when you look at all of these, 4x minus 1, x cubed, x squared, any of them are any of those radicals? See your radical symbol?
No.
Okay, and the other thing with that, you don't want to just look for the radical symbol, right? You also want to look for rational exponents. Fraction as exponents, right? That, if you have a rational exponent, that's a radical. Okay, so you're looking for those rational exponents or the actual radical symbol. Is that the case in any of these? No. Any of them have denominators? No. You can write them, right? It'd just be 1, but that doesn't do anything. Okay. So are those, of those 3, any of them, those 2 cases that we talked about? No. So if that's the case, what is the domain? Look at the graphs. First one is just a line. Yeah, I can plug anything in, right? It goes, and when you look at a graph, you're looking at how far left and right you go for domain, right? Is that ever going to stop going left and right? Cubic function, is that ever going to stop going left and right? Parabola, quadratic, is that ever going to stop going left and right? have no restrictions with those ones. Okay? Of those three, will they have restrictions? All three of them? Which one or which one or two, whatever, which ones have restrictions actually? The square root of x minus 6, that'll have a restriction, yep. First one, x to the 1/2. What's x to the 1/2? Okay, so again, don't just look for the radical symbol. You have a rational exponent, and if it helps, rewrite it. I told you how important it is to be able to rewrite, correct? Okay. X to the 1/2 is square root of x.
Why is that? But that would have been a negative or a 0.
Say that again.
How is that one not going to be relevant about real terms? There's no 0 at the bottom.
Oh, you're saying this one?
Yeah.
Okay, so it's x, right? X is a variable. It can be any number. So we're going to figure out the values that cause it to be negative. I'll go through that. That's what I'm going to talk about.
Okay.
Okay. Will this have a restriction? No. It's an odd index, right? So in this case, x is the element of all real. Now, we said we can't have any negatives under that radical, correct? Yep.
That little symbol?
It's-
That's in the, not the symbol.
And we said we can't have any negatives inside that radical, right? So what you're going to do is you're going to take the radicand. The radicand is that part that's inside the radical, right? Okay, in this case is x, and you're going to set it equal to 0. Nice thing about this one, you don't have any steps to solve, right? It's literally just x equals 0. When we go over here, then we got to add 6 to both sides, right? So when I do that, set the radicand equal to 0 and I solve, that's the value that's going to cause the inside to be 0, correct? Can I take square root of 0, fourth root of 0, fifth root of 0, whatever? It's just 0, right? So that's basically that point where if I go left or right of it, I'll get positive or negative, won't it? Then we said we can't have the negatives. Okay. What's that?
Why?
Say that again.
I can't do that again?
What's the square root of negative 1? Can you do that without over the real numbers? Okay, so those are the values we have to exclude.
Oh.
Okay, that's what we're trying to figure out, those values that are going to cause that. Okay. So what I think about, okay, if I think about a number line. Okay, 0 is that point where it's 0, right? If I go right to that 1, if I go left to that, that's negative 1, correct? Can I plug negative 1 in? Can I plug negative 1 into here? It's going to cause it to be negative inside, right? Negative 2, same thing. Negative 3. Okay,
What did
so
I miss?
we're on the second page, bud. Okay, so everything to the left of that 0 are the values that won't work, correct? Everything to the right does. And when I ask for that domain, I'm asking for the values that do work, correct? That will be part of everything. But then we'll say such that x has to be what compared to 0?
Not equal to.
Okay, and we said everything to the right will work, right? Positive values, right? What inequality symbol represents to the right? Greater, right? So values that are greater than 0 will work. 1, 2, 3, those work, correct? can I include 0? Square root of 0 is just 0. I get something back, don't I? So our domain, x includes everything such that x has to be greater than or equal to that 0. So again, when you get these radical symbols, it's a set of numbers, right? We had to exclude everything that was less than or equal to. Okay? Now when I go over here, x is compared something to 6, right? So let's do that number line over here. Got 6, 7, 5. 6 was that point that caused it to be 0, right? That's going to work. Now if I plug 7 in, 7 minus 6 square root of 1, can I do that?
Yeah.
8 minus 6 square root of 2, does that work? Okay, if I plug that value to the left then, 5 minus 6, negative 1, square root of negative 1, does that work? No. So everything to the right of 6 and including 6 works, correct? So x is the element of all reals such that x is what to 6?
Greater.
Greater than or equal to. Okay. So figure out that point that causes it 0. Then think about those two values to the left and right of it. Okay. The ones to the right worked. Values to the right are greater than or equal to, correct? Values to the left are less than or equal to. Okay. Don't just assume it's always greater than or equal to. Typically it is. But if I start throwing like a negative symbol in here, let's do that one actually. Okay, you'd set that equal to 0, right?
It'd have to be negative 6 or lower.
Okay, so you'd set that radicand equal to 0. Get negative x equals 6. X equals negative 6, correct? So that point is negative 6. Now, if I plug in negative 7, negative 7, that's 7, right? 7 minus 6, 1. Does negative 7 work? So if I go negative 5, negative 5, that's going to be positive 5, correct? Minus 6, negative 1, right? So in this case, the values to the right didn't work, correct? The values to the left worked. So in this case, x would have to be what compared to that negative 6? Less than or equal to that negative 6. So don't just assume it's always greater than. Okay? Think about those surrounding values of that one that caused it to be 0. Just plug them in. Okay? The negative 7 worked this time. The negative 5 didn't. So the values to the left work while the values to the right don't. Okay, and there's the graphs to those. And we'll start graphing them next week. Okay, you notice how the square roots just have one tail? Okay, because we have that restriction, right? I can't, on this one we said we couldn't plug anything less than or equal to 0, right? Don't get anything back. On this one we said it had to be greater than or equal to 6. So anything to the left of that doesn't work. I don't get anything back when I plug those values in. Cube root, right? I can take the cube root of negative 8. So I can't have those negative values in those odd index radicals. So cube root, fifth roots, we get two tails. Okay, so of these three, okay, this is the other case, right? We dealt with the radicals. We've actually dealt with these already, didn't we? Can't have a variable in the denominator. So of those three, Which ones have restrictions? Second and third one do. Okay, the first one, there's no radical and there's no variable in the denominator, right? The denominator will always be what on that first one? Always going to be 4. No matter what x is, it's always 4. So what's the domain of the first one? X is the element of all real numbers. I can plug anything in. The next two, I can pick an x value that causes the denominator to be 0 though, right?
Yeah.
And that's the value I have to exclude. So we're going to use that same idea. You're going to set the denominator equal to 0. Then you don't even need another step with that one, right? This one we will. 2x equals 3. X equals 3 halves. Because if I take that value now and plug it in, it causes it to be 3 over 0, right? Can I do 3 divided by 0? No. So that is a specific value that I can't use, right? Is there any other values that's going to cause that to be 0? No. So when I write this domain, I want everything except for 0. Now know the difference, okay? Variable with the denominator with the variable, it's a specific single value. Well, in this case, a single value, right? With those radicals, we're excluding a whole set of numbers. So radicals, you'll have an inequality. Denominators, it's just a specific value. Okay? A lot of people get that part mixed up. When do I use does not equal? When do I use an inequality symbol? So know the difference there. Okay, so then on this one, if I plug 3 halves in, that's what caused the denominator to be 0, right? 2 times 3 halves, that's 3. 3 minus 3, 0. Doesn't even matter what the numerator is, right? Denominator is 0. So what's my domain here? X cannot equal that 3 halves. Questions on that page? And we've kind of dealt with these ones already, haven't we? When we did our rational functions unit. Okay. Think we'll have a restriction? Even index, right? Okay, so we got to make sure that we can't get a negative in there. So we set that radicand equal to 0, right? So x squared equals negative 3. It's weird, isn't it? I don't get a specific value. Is there any values that's going to cause that radicand to be negative? No. Why?
Because it's getting squared, of
It's getting,
course.
it's getting squared. So even if I picked a negative value, let's say negative 10, and I evaluate that, f of negative 10, that's saying negative 10 squared plus 3, correct?
Yeah.
I'll never get negative in there. So that one, the super important thing that we said right at the beginning, said no negatives inside the square root, right? Or no negatives inside an even index radical. Can we ever get negatives? So is there a restriction? No. Now what if I change that up a little bit? Could that?
Yeah.
Because we're subtracting, right? So when you're thinking about it, we're squaring this, so I'll always get a positive value here, right? And if I'm adding a positive value plus a positive value, I'll always get positive. Here, always a positive minus 3, right? So in this case, I would, and we're not going to go over that. Don't worry about that one. But this one would. So don't just assume that if it's x squared, that doesn't, there's still possibility that there's a restriction. We got to look at that second part too. How about this one?
Well, there's two things you have to keep in mind. One, you can't have the x be 0 or be a negative in the square root.
Yep.
And you can't have the bottom be 0.
Good. So we got both cases here, right? We got the even index radical and the variable in the denominator. Still use those same ideas. Okay, we got that x minus 3. That's the radicand, set that equal to 0, right? So x equals 3.
Yep.
And again, that was under the radical, so that's going to give us an inequality statement. We got to exclude a set of numbers, correct? Which values work? The ones to the right or to the left?
Right.
To the right. So based off this, x has to be greater than or equal to that 3, correct? Now, with the other part, okay, set the denominator equal to 0, right? Does that factor? Yep, into. So x plus 2 equals 0, x equals negative 2, x minus 7 equals 0, x equals 7. So those are two values we have to exclude, right?
Well, one of them's already being excluded.
Good. Okay, so let's think about our domain on the number line. Okay. Based off that radical in the numerator, we have to have greater than or equal to 3, correct? Okay. So that would be the domain if we just had the numerator, correct? Now, going off the denominator, x cannot equal negative 2. Is that even part of our domain right now? Okay, so it's already excluded, isn't it? But what about that 7?
Yeah, that's in the domain, so we have to take it out.
We got to get rid of that 7. So in this case, x is the element of all the reals such that we've got restricted with that radical being greater than or equal to 3 too, right? But what else do we have to say?
X does not equal 7.
So x is the element of all the reals such that x has to be greater than or equal to 3, and x cannot equal that 7 as well.
Pretty simple.
Questions on that one? If you followed that one, you should be sitting pretty good with domains. Okay, so for this lesson, 7.3b homework. It's a 7173 practice. Okay, a lot of them, but most of them are pretty quick. Okay. All right, the other thing I want to do, we're going to go over that common assessment from yesterday. So, who still needs to take that? Okay. Why don't you guys